Types of angle pairs. In this video, we'll answer the questions, what are the characteristics of each angle pair? And how can I recognize these pairs in new situations and recall their characteristics? Two of our angle pairs are called our congruent angle pairs. The first are vertical angles. Vertical angles are non-adjacent angles formed by intersecting lines. But that definition is a little bit heavy, so I like this informal definition too. These are angles that are across from each other. Now, angle 1 and angle 2 in this case appear to be on the left and right side of this four-angle intersection, but the top and the bottom angles also form their own vertical angle pair. So in each set of intersecting lines, there are two sets of vertical angles. We next have the angle bisector. The angle bisector is a ray that divides an angle into two congruent angles. It's not necessarily the pair of angles that is angle bisector, it's technically just that ray, but angle 1 and angle 2 are formed by the angle bisector. The informal definition is a ray that cuts an angle exactly in half. Now, those are the characteristics of the angle pairs, but we actually also want to understand the relationship between angle 1 and angle 2 in each of these angle pairs. And that's that angle 1 is congruent to angle 2. Remember that congruency means objects that have the same size and shape. But we're also going to represent that relationship in a more numeric sense rather than an object sense, and that's that the angle degrees are equal to each other. We'll see this evidence of having congruency with sometimes markings on the angle pairs, this little arc that shows that two angles are congruent. That would be evidence that we have congruent angles. These two representations of the relationship of congruent and equal, congruent means that the object has the same size and shape, but equal means that numbers are the same, like 40 degrees and another 40 degrees. So these are two different relationships for the same. Our final two angle pairs are angle pairs with specific degree measures. The first are complementary angles. Complementary angles are angles that add to 90 degrees. You'll see a box sometimes as evidence that we have complementary angles. Next are supplementary angles. Supplementary angles are angles that add to 180 degrees. There's one specific case of supplementary angles if you join angle 1 and angle 2 together. We call that a linear pair. A linear pair are adjacent supplementary angles. Adjacent means that two angles share the same vertex and one ray, that ray that's coming out of the vertices of angle 1 and angle 2 up and to the right. These are called a linear pair because angle 1 and angle 2 are a pair of angles that form a line, hence linear pair. Let's talk about the relationship between what these types of angles represent. It's that part plus part equals a whole. Two parts add to a whole. In an equation, if you were to write an equation, we would have for complementary angles that angle 1 plus angle 2 equals 90. For supplementary, angle 1 plus angle 2 equals 180. So these types of angle pairs are instances of the angle addition postulate. Part plus part equals whole. Now that we have knowledge of all of our angle pairs, let's answer what do I need to do with all of these angle pairs? First, we'll need to recognize angle pairs in a variety of situations. Then we'll need to recall characteristics about each angle pair. We'll then apply those characteristics to write a model equation to represent what those objects mean. We'll solve that equation and finally evaluate the reasonableness of our solution. Those last three steps, 3 through 5, we'll cover in our next video to better segment these concepts. We'll focus on recognizing and recalling in this video. Let's look at some angle pairs in context. Here we have a rectangle and we're given two angles that form an angle pair inside of this rectangle. Let's use evidence-based reasoning to categorize this angle pair. Am I given any useful information in the directions or names? Do I recognize any markings in my picture that are evidence of an angle pair? Well, let's make that connection. If I consider only this one angle pair, which one that we've learned about does it match with? That green box we now know means that this angle pair is a set of complementary angles. So, what does this mean to be complementary angles? That's our final conclusion with reasoning. What does this mean? Because these angles are complementary, they add to 90 degrees. Let's look at one final angle pair in context. We have a triangle and we're given an angle pair which we need to categorize. Let's use evidence-based reasoning again. Am I given any useful information in the directions or names? Well, we're given that we have a triangle, but that doesn't help with our angle pair categorization. That's only that we have a polygon with 3 angles. But boy, do we want this angle to be complementary or adding to 90 degrees because it kind of just looks like it's 90 degrees. But that's just intuition. That's not really evidence or proof. So instead, we'll recognize markings that we have in our picture. And sure enough, we have these congruent angle arc markings. So let's make a connection. If I consider just this one angle pair versus anything else in the triangle, which one of our angle pairs do we have a match with? So we actually have an angle bisector since we have 2 congruent angles or one angle being cut into 2 congruent halves. So let's make a conclusion about the relationship between these 2 angles. Our conclusion with reasoning is that because these angles are formed by an angle bisector, as evidenced by their congruence markings, they are congruent to each other. So that question mark here would be 46 degrees versus maybe what we would have guessed before. If we thought they added to 90, we might have thought there was 44 degrees. But we have congruent angles instead.